Why do different places on Earth have different sunrise and sunset times? The time of sunrise and sunset is constantly changing throughout the year. The sun does not always rise and set at the same time each day, but the time varies depending on the season, the geographical location, and other factors. This means that even if two places are located close to each other, they may experience slightly different times for sunrise and sunset. This can make it difficult to plan activities during the day. As a wise man once said, it's all in the timing. If you ask a sky watcher, they'll tell you that it has to do with the Earth's rotation and the position of the sun. But if you ask me, I'd say that it's because of the Earth's amazing ability to bring us the most stunning sunrises and sunsets, no matter where you are. The answer to why different places on Earth have different sunrise and sunset times is a combination of two things: the Earth's tilt and orbit around the sun. The Earth spins around like a top. It takes 24 hours for a full spin, which is like a day. The Earth also takes a trip around the sun once a year, which is like a really long 365-day trip. Our planet spins at an angle of 23.5 degrees, so it can make it all the way around the sun. The Earth is like a ball with a line going from top to bottom in the center. In one half of the ball, it's summer and the sun is up for a long time, but on the other side, it's winter and the sun is up for a short time. That's why the sun is up for different amounts of time in different places on the Earth. The Earth's tilt is the main cause of the variations in sunrise and sunset times around the world. The Earth's axis is slightly tilted relative to its orbit around the sun, which is why the northern and southern hemispheres receive different amounts of sunlight at different times of the year. This is the reason we have seasons. This tilt also affects the length of day and night, or the duration of the day cycle. The location of the sun in the sky at any given time is determined by the angle of the Earth's tilt in relation to the sun's rays. The Earth's orbit around the sun is also a factor that determines when the sunrise and sunset times occur. The Earth's orbit is slightly elliptical, meaning that its distance from the sun varies over the course of the year. This affects how much sunlight the Earth receives and affects how long the days and nights are. The combination of the Earth's tilt and orbit around the sun produces different sunrise and sunset times around the world. As the Earth rotates, different parts of the world experience different lengths of day and night. This is why different places have different sunrise and sunset times. Each location has its own unique combination of the Earth's tilt and orbit around the sun. The fact that different places on Earth have different sunrise and sunset times means that the world is constantly changing and evolving. It also means that each place has its own unique culture and way of life, based on the amount of light each location receives. Did you know that some places on Earth have constant daylight? It almost never gets dark. The sun never sets in certain places due to the same reasons, which are Earth's tilt and the rotation around its axis, resulting in the sun staying above the horizon for days or even months in areas above the Arctic Circle or below the Antarctic Circle. On December 21st or 22nd, the winter solstice takes place, leading to the shortest day and the longest night of the year. After the winter solstice, the daylight hours, the period of time between sunrise and sunset, become longer and longer, even though it may be hard to notice right away. The shape of the orbit is elliptical rather than circular, and the Earth's axis of rotation is tilted at an angle to the plane of the orbit. This causes the times of sunrise and sunset to differ as the Earth moves around its orbit. It is evident from an astronomical almanac or a calendar displaying sunrise and sunset times that the sun does not rise and set earlier or later by a fixed number of minutes each morning and evening. At the beginning of the year, the sun rises a little earlier each day. For example, in Berlin on February 1st, 2009, the sun rose 25 minutes earlier than on January 1st, but set 45 minutes later. Although the change is not symmetrical, the point when the sun is highest in the sky, solar noon, still occurs halfway between sunrise and sunset. The amount of time between sunrise and solar noon remains relatively consistent with the amount of time between solar noon and sunset. The sun rises slightly earlier each day, but still reaches its peak in the sky at midday. This leads to a gradually increasing delay as the days get longer. How is this possible? The Earth does not travel in a perfectly circular orbit around the sun. Rather, its orbit is slightly elliptical. This means that the speed of the sun's movement across the sky differs day to day, sometimes faster and sometimes slower. Additionally, the exact path of the sun is distinct depending on the season of the year. The sun's path across the sky changes daily due to the fact that the Earth's axis of rotation is not parallel to its orbit around the sun. Depending on the season, either the northern or southern hemisphere is tilted towards the sun, causing a variation in the sun's path. You know how our clock suddenly changes time and goes back 1 hour during winter? That's called the winter solstice. The winter solstice marks the longest night of the year and the official beginning of winter. So what do you get when you combine the longest night with the shortest day? The perfect opportunity to stay up late, snuggle with your favorite blanket, and watch the sunrise. So what is a solstice? At certain times of the year, which are the two solstices in June and December, and two equinoxes in March and September, the seasons change astronomically due to a combination of factors. The relationship between the Earth and the Sun, along with the tilt in the Earth's axis. The summer solstice, which starts in June in the Northern Hemisphere, is the longest day of the year with the most daylight, while the winter solstice in December marks the start of winter in the Northern Hemisphere and summer in the Southern Hemisphere. This phenomenon takes its name from the Latin words sol for sun and sistere for to stand still. In the most northerly regions of the planet, days or weeks may pass without the sun actually setting below the horizon, and vice versa for Antarctica. Scientists consider these dates to be the boundary between the seasons for all of us on Earth. The solstice is an important event that has been celebrated for thousands of years, most notably in the form of Christmas, which includes many of the same traditions from ancient pagan rituals. So why do we have seasons exactly? The axial tilt of the Earth at 23 degrees is the cause of the planet's changing seasons. Without it, life on Earth could have developed in a different way due to more stable temperatures and climates. This tilt causes the northern and southern hemispheres to be more or less exposed to the sun's rays throughout the year, leading to fluctuating temperatures, different meteorological conditions, and periods of increased and decreased light and energy, which we refer to as seasons. The equinoxes are the moments when the Earth's equator passes the same plane as the sun's equator, and occur twice a year in March and September. They mark the beginning of the spring and fall seasons and are called equal night because of the roughly equal amounts of day and night at most locations. Watching the sunset or the sunrise is one of the most romantic activities one can choose to do to have a spectacular view without even trying. So let's dive a little deeper and elaborate on why our sunsets and sunrises look like they do. We asked ourselves, how does the atmosphere affect sunlight? It was discovered that our eyes can detect a part of the sun's emissions known as the visible spectrum, which is an electromagnetic radiation ranging from high-frequency gamma rays to low-frequency radio waves. This visible spectrum, which we generally refer to as white light, consists of 7 distinct wavelengths that are commonly known by the acronym ROY-GBIV. In summary, the same electromagnetic radiation is received by different planets at varying intensities. I am curious to know if the colors of the sky and sun vary from planet to planet. It should be noted that apart from the sunlight, the colors we perceive are dependent upon the medium through which the light is traveling. Light behaves in diverse ways when interacting with various particles. Upon encountering a particle, the light may be either absorbed, reflected, or scattered. Scattering of light occurs when particles interact with light, resulting in some wavelengths being removed and the resultant color that we see changing. The amount of scattering that occurs depends on the type of particle involved, with some particles preferentially scattering longer red wavelengths and others shorter blue waves. For instance, in the vacuum of outer space, where there are no particles to obstruct or absorb the light, the sun appears to be of a white hue. Could you try to explain why sunsets on Earth look red? It has something to do with a phenomenon called Rayleigh scattering, whereby the size of particles is much smaller than the wavelength of the light. The small nitrogen and oxygen molecules contained in our Earth's atmosphere work to scatter the blue wavelengths, thereby allowing the red wavelengths to reach our eyes by the time the light reaches us. Have you ever wondered what a sunset looks like on another planet? Let's take a quick jump to Mars and see what its sunset looks like. Upon analyzing the Martian sunset, we can readily observe two notable features, namely the bluish disk of the sun and the fading blue halo surrounding it. Let's go through what causes this phenomenon. The sun on Mars has a blue hue due to the Martian atmosphere filtering out the redder wavelengths. The dust size on Mars is perfect for scattering red light, so these particles scatter red wavelengths more than the blue ones, making the sunlight travel the longest distance during sunrise or sunset, resulting in a bluish disk. This phenomenon is known as wavelength selective extinction, which is the Martian atmosphere's ability to filter out red light and let in blue light. What is the source of the blue halo surrounding the sun? The blue hue around the sun on Mars is caused by a combination of wavelength selective extinction and scattering, where the light is scattered in the forward direction, causing a concentrated blue halo. Blue light intensity is 6 times greater than red light in the forward direction, with the maximum intensity at a scattering angle of 10 degrees. As the scattering angle increases, the dominance of blue wavelengths decreases and the bluish glow fades into the reddish-gray sky. If you are disappointed that the only way to witness this blue sunset is to venture to Mars, you'll be pleasantly surprised to hear that they have been seen on our own planet too. It's not super common, but it happens. In 1883, locals of the area around the Krakatoa volcano reported that the sun and moon had a bluish hue for an entire month after the eruption. It was so cool. The first description of a bluish halo around the sun, surrounded by a brownish ring, was made by Reverend Sereno, a bishop in Hawaii. This phenomenon, caused by the volcanic dust particles released into the atmosphere due to an eruption, has been aptly named the Bishop's Ring. Besides volcanic eruptions, blue sunsets have also been occasionally reported in the deserts of Arabia, where dust storms are frequent. Sometimes forest fires can also lead to red skies and blue sunsets. Sunsets are one of nature's most beautiful gifts. We can thank the Earth's tilt and orbit around the sun for the different sunrise and sunset times around the world. The combination of these two phenomena produces the stunning colors in the sky at the end of the day. Sunsets look red due to the Rayleigh scattering of sunlight in the atmosphere. The size of particles in the atmosphere is much smaller than the wavelength of the light, so blue wavelengths are scattered while red wavelengths are allowed to reach our eyes. These amazing natural events are a reminder of the beauty and diversity of our planet. That's all for this video. Thanks for watching. Don't forget to like and subscribe to follow up with all the exciting topics regarding astronomy.